Hello guys, in this video we are going to talk about Lewis structures. We are going to go over a couple of examples including resonance structures. So let's remind us that atoms actually gain, lose, or share electrons in their valence level in order to achieve a greater stability, which is going to be a lower energy state. The octet rule tells us that atoms try to achieve the electronic configuration of the noble gas nearest to them in the periodic table by achieving a full valence level of 8 electrons. So remember that the main group number actually in the periodic table tells us how many valence electrons do we have. So the noble gases are going to have 8 valence electrons, and there is only one exception, which is helium, which is going to have only 2 valence electrons. That is why hydrogen and helium are only need 2 valence electrons to have a full valence level. Okay, I hope this makes sense. Let's jump into the rules and look at some examples. So let's start with carbon tetrachloride, CCl4. Now, the first step is in drawing a Lewis structure to sum the valence electrons from all atoms, taking into account an overall charge. So we know that CCl4 has no overall charge, so we only have to take a look at the number of valence electrons. So let's go to the periodic table. We can see carbon right here, chlorine right here, which is going to have 7 valence electrons. Carbon is going to have 4. So 4 plus the 7 valence electrons for chlorine times 4, because we have 4 chlorine atoms, we are going to have a total of 32 valence electrons. Okay, step number 2, write the symbols for the atoms, show which atoms are attached to which, and then connect them with a single bond. Well, first of all, we have to figure out which one is the central atom. Generally, the central atom is going to be the atom of which you have only one, in this case, carbon, but you can also look at the electronegativities. Generally, the atom with the lower electronegativity is going to be the central atom, and it's true in case of chlorine and carbon also, because carbon has a lower electronegativity. Okay, so carbon is our central atom, and we are going to use bonds to connect those to the chlorine atoms. Remember that each bond actually contains a pair of electrons. So for each bond that I drew, I have to count 2 electrons. So in this Lewis structure, I already used up in 4 bonds 8 electrons. So I have to subtract that from the 32 valence electrons, which is going to leave me with 24 valence electrons. Then I need to complete the octets around all atoms bonded to the central atom, meaning I need to have 8 electrons around all the chlorine atoms. In order to do that, because I already have 2 electrons next to each chlorine atom, I need to add 6 more. So 1, 2, 3, 4, 5, 6. Now this chlorine atom is happy because it has an octet around it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And the 2 more in each case are in the bonds. So I used up 4 times 6 electrons, which is actually 24. So this means that my Lewis structure is complete if every single atom has 8 electrons around them, except for hydrogen, which is going to need only 2 electrons around it. So let's double check. I have 2, 4, 6, 8 electrons around my carbon atom, and I know that I drew the extra electrons for each chlorine atom to have the octet. Okay, I hope this makes sense. Let's take a look at another example. Let's do one of my favorite molecules, water, H2O. Okay, so periodic table, hydrogen is right here, is going to have 1 valence electrons, oxygen is right here, is going to have 6 valence electrons. So the sum of the valence electrons is 2 times 1 for the hydrogen atoms plus 6 for the oxygen atom, which is going to give me 8 electrons. Okay, now I have to write out the symbols. So oxygen is actually going to be the central atom in this case because we have only one of that. And then I'm going to use 4 electrons in 2 bonds to connect that into the hydrogen atoms. So now I used up these 4 electrons. So let's keep track because I still have 4 more. Question. Do I need to complete the octets around all atoms bonded to the central atom? Do I need 8 electrons around the hydrogen atoms or only 2? Only 2, right? So hydrogen and helium will always have only 2 electrons around them. So in this case, my hydrogen atoms are happy. What do I do with the remaining 4 electrons? Well, I'm actually going to place those electrons on the central atom. So 1, 2, 3, 4. Okay, and my Lewis structure is actually ready. Now, if you are learning about the different molecular shapes, remember that actually water is not linear. So generally another way of drawing water is going to be this. Water molecules are bent and we are going to put the extra lone electron pairs on the central atom like this. Okay, I hope this makes sense. So both way of drawing the water molecule is correct, but if you actually would like to show the molecular shape, then use this structure. All right. So what's next? Let's do another example. Let's do the nitrate ion, okay? It's getting more interesting because we are having an ion. Let's see how can we make every single atom happy there. So the nitrate ion is NO3 minus. Let's go to the periodic table. Nitrogen has 5 valence electrons. Oxygen has 6 valence electrons. So 5 plus, for the 3 oxygen atoms, 3 times 6. Do I need to add more electrons? Yes, because this is an anion, so I have to add 1 electron for each negative charge. Since it's 1 minus, I need to add 1 more electron. So this is going to give me a total of 24 valence electrons. All right, now let's figure out which one is the central atom. Nitrogen, right? So I'm going to put the nitrogen atom in the center, and then I'm going to use 3 bonds to connect the single nitrogen atom into the 3 oxygen atoms. So this means that in 3 bonds, I used up 6 valence electrons, right? So I still have 18 valence electrons. Now I have to complete the octets around all atoms bonded to the central atom. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so now I used up all 18 of my electrons. There is no remaining electrons. But what do I do with my nitrogen? Is my nitrogen happy or not? It's very unhappy right now because it also needs to have 8 electrons around it. But there is actually a solution if there are not enough electrons to give the central atom an octet, we can do multiple bonds. So what I'm going to do, I'm simply going to say that, hey, I'm going to erase this pair, okay, so it's not there at all anymore, and I'm placing a double bond right here. Okay, is my nitrogen atom happy now? Yes, it is. Are all my oxygen atoms happy because they have 8 electrons around them? Yes, they are. All right, one more thing is missing. Actually, because it's a negatively charged ion, I have to add brackets around it and show the negative charge. Now, is this a structure that can completely describe the bonding in the nitrate ion? No, it's actually not, because I could have chosen any other of the oxygen atoms to put the double bond in it, right? So actually, in this case, I will need to use resonance structures to fully describe the bonding in the nitrate ion. So resonance structures are simply a set of 2 or more Lewis structures that collectively describe the electronic bonding. So what are the other resonance structures for the nitrate ion? Well, in case of resonance structures, I simply have to move around the electrons. So what I'm going to do, I'm going to move around the double bond. So in the next resonance structure, and I'm going to make it a little bit smaller because that 18 is right there. By starting with the bracket, I have nitrogen, the central atom, and let's put the double bond right here and the single bonds right there. Let's add all the electrons to make every single atom happy. Okay, like so, and the negative charge. Okay, is there any other spot where I can put the double bond? Yes, I can actually place the double bond also next to this oxygen atom, like this. So the brackets and adding the extra electrons. So 6 electrons around each oxygen atom that has only a single bond, and 4 electrons around the oxygen atom that is double bonded. Is there any other way how I can draw this structure? No, these are all the 3 resonance structures that are possible for the nitrate ion. Okay, I hope this makes sense. We are going to talk more about Lewis structures, formal charges, and resonance structures in the next video. See you there.